Good morning, colleagues, and thank you, Mr. Sanel. There are two pieces of news for you. One is that my presentation is going to be short, and the second is that I don't have a PowerPoint. Personally, I am allergic to those, so I also think I should not inflict the same on others. I am from Ministry of Power, and I look after distribution of power. One of the most ticklish aspects of power is distribution. Distribution of power is not what exactly it means. It also means all the grids which you see, the consumer interfaces, and also interesting things like tariff, load shedding, and lastly, and most importantly, it is the revenue point in a very large, one of the most critical sectors of our infrastructure in the country. The revenue in power sector is generated in the distribution sector, and this is the area where we face some problems. All other problems of generation, capacity being built, etc., have its root causes in not adequate revenue being generated on various accounts. Now, I implement a program, and which, as the government programs want, is very complicated name, Restructured Accelerated Power Development Reforms Program. Basically, it seeks to reduce the level of losses. I mean, we lose about 30% of the electricity which we supply in the country. Lose means that either somebody doesn't pay for it, or it is lost on account of bad state of the grid. Now, no business could sustain itself if you lose 30% of your revenue generation, and neither does power sectors. So our annual losses in the power sector are in the region of 35 to 36,000 crores, which all of us collectively pay via taxation. I mean, it's not that it goes unpaid for. So we all pay through tax, and maybe few of us steal and enjoy free power. So this is the way it is. This also, unfortunately, since we do not know where our consumers are, we are not very sure as to who is consuming how much amount. The thieves do not tell you how much they are going to consume and when they are going to consume. We are unable to plan our distribution grids. And if we cannot plan our distribution grids, what happens is that you have unannounced load shedding. It results in poor quality of power, which is known as brownouts. It also results in higher tariff being paid by those who legally pay. And last but not least is that the equipment life gets reduced very significantly. Now we're talking of power, which is the most expensive infrastructure, piece of infrastructure. So equipment life has a huge meaning over here. And so the investments which we make today in the power sector will not reach fruition unless we correct those problems. Now we are introducing the use of ICT, Information and Communication Technology. We are digitalizing our distribution grids, basically to set up a basic electricity audit and accounting system and on our grid. That is to know, we know at each point of the grid who is consuming how much in a real-time basis. Now for that I require some automatic readers. I pull data at regular intervals. I collate this at some points with the aid of servers or some things like that. And I have a very strong communication base for that. Now, once we do that, we will have a fairly decent idea as to where our energy flows are going, and we can control those. We can take the corrective action. As a huge program, we are doing it countrywide. We think it will cost us somewhere in the region of 9 to 12,000 crores. And once we do that, we'll at least be sure what is happening to our electricity, and then we can tackle it. Apart from that, we also propose to invest into the grid to make them more intelligent. Of course, the word used to be intelligent until the last couple of years back. Now smartness is in vogue. So, well, we'll have a smart grid, So we always thought it was an intelligent grid. Maybe we were out. So it is smart grid now. The credit for this obviously should go to US government and the Obama administration, who actually have invested quite a large amount of their fiscal stimulus package into the smart grids, which is basically rolling out intelligent or smart meters. Which are these smart meters? These smart meters are going to be in the house of the consumers. These smart meters will enable two-way communication between the consumer of the electricity and the supplier of the electricity. Now, to give a practical example of this, if you in your house, you have a smart meter, and I am a utility. Now, I have a problem because I have less amount of electricity, and you all are consuming electricity. So if there is a two-way communication, I will say, I have less amount of electricity at this time, so I'm going to price the electricity higher. So you can decide that you will shift some of your consumption. Some consumption is choice-based. I mean, running your washing machine, for instance. I'm talking about a very micro level just to make it clear. You can shift it, let's say, in non-peak period. Okay? There, the incentive for you would be that I will charge you a lower amount of tariff. So in a sense, my peak load means the peak demand for electricity can be staggered across the day, and I need not build very expensive generation plants. I mean, 1 megawatt plant costs around 6 crores, okay? So I need not build so many expensive mega power plant, invest in the infrastructure, if I can manage my loads. Now, this can only happen if the consumer is enabled to take these acts, and there's a very effective communication interface with both of us. If you're looking further, you can in fact leave this job to an intelligent meter. You can say, if the price of my power goes beyond this price, these activities like air conditioners or this will not work. So the meter can take care of that. Okay? You need not do that. You can program this like this. Well, that's our idea of smart grids. The smart grids are also required to integrate the increasing number of renewables. We all like to have green cities, green energy. You want to have solar energy, you want to have wind power energy. But the problem with all renewables is that they are blessed by Mother Nature, but they are also unpredictable. So you can have wind, which can drop in half an hour, and your generation of your power will go away. But the need of electricity to be consumed at that particular time may not go away. And that's not linked to the wind. If the wind flows, that doesn't mean that you will start consuming more electricity. So there is going to be a mismatch. To deal with this mismatch, if you keep on consuming that amount of electricity and your projection of your renewable electricity goes down, the net result of this is going to be a collapse of your grid. And the grid will collapse. You won't have electricity. Now, this costs the economy a huge, huge amount of money. When we talk about efficiency of economy, we are in fact talking of efficiency of your infrastructure, which contributes in a very significant way to our industrial efficiency or commercial efficiency as well. Now, we cannot afford to let our grids going up and down just like that. You know, you will be stuck in metro, you will be stuck in trains. I mean, if the grid collapses, a lot of things can happen here. So, what do we do there? So, we have to have very fast responding in real-time basis, intelligent grids, which would be shifting loads and managing this through a very complex architecture. Now, if we have a manual interface, this is never going to work. But there is always a lead time. So, you will have to have a merit order dispatches, etc., built in, and inherent logic for managing the grid fed in at various points in the grid, which will automatically take care of the shifting production of electricity and shifting consumption of electricity. And last example which I'd like to give is what we think in future is going to be electricity vehicles. Now, electricity vehicles is again a very nice idea. It could be a reality. We expect this to be a reality in a decade. Now, if you have electricity, your consumption is always be shifting. You will drive your car from Claridge's to your home and charge the car. And then you may go to a shopping mall and you may charge it there. Your grid is static. The transformer which was fixed at your... Now, this is the infrastructure which underlays that. So those are the challenges which we face today. The APDRP program which we are implementing is actually laying down the foundations. When we accurately measure the electricity which is being flowing at various points of the grid, this is the starting point. This is the building block on which we will make smart grids of the future. So unless we do this, we really cannot go ahead. Whether we go ahead or not is a matter of choice, matter of technological development. But we cannot do that unless we have this foundation laid now and today. The drivers for laying this foundation today maybe loss reduction, but the same system which is being laid today as foundation for electricity audit, accounting, monitoring will enable us tomorrow to be able to tackle the challenges which will be posed by these future technologies in various sectors, which in sum total will constitute what smart cities of future will look like. Thank you for your attention, and I take your leave now.